This is number 13. It has the same directions as number 12. We're using the definition of a derivative and the limit process to find a derivative. So here we have a trig function this time. This one should be in your notes. We've done this so many times. Well, I guess we'll do it anyways. So f prime of x. So I'm writing the definition of a derivative first. So that's the limit as h goes to 0 of f of x plus h minus f of x over h. Some books have delta x. In fact, our textbook has delta x, but I prefer to write the letter h. Alright, let's plug in the information we have, or plug in the function we have. So our function is sine, so it's sine of x plus h minus sine of x over h. We're going to use sum of two angles formula. I hope I remember it correctly. So it's going to be sine x cosine h plus cosine x sine h. Right? Sine of the angle times cosine of the angle. Then reverse the roles. Cosine of the angle times the sine of the angle. Copy what's left. Continuing on. Alright, what we got? Okay, what we want to do is get things together and get it in the form that we know. Okay, what forms do we know? Or what am I talking about? We know these limits. We know the limit as h goes to 0 of sine, I don't know why I chose h, but it's the same thing. Sine h over h, we know that to be 1. H goes to 0 of cosine h minus 1 over h. That's 0. Okay, or I can have the other. I can have 1 minus cosine h. Same idea. Alright, so we're looking for those two. We see that there's a sine x common heat between these two. So I'm going to group those together. And remember, a fraction can be written with the denominator. I'm sorry, what I'm doing is I'm going to group those two together, put it over h, and write that as one fraction. And then I'm going to write cosine x sine h over h as another fraction. Alright, now I'm going to rewrite it so that you can see these two limits. We'll make it easier to see. So here, I'm going to take out the sine x. And it's cosine h minus 1 that's left. And I'm going to put that over h. This is the same thing, right? I've taken out a sine x. I just didn't bother to draw the line extra long. But I'm doing this for emphasis that I'm finding, I know what the limit of this is. The cosine h minus 1 over h. Same thing here. I'm just rewriting it to make it obvious that the limit we know about. Okay? We know this limit, sine h over h. Now we can take the limit. The limit of, and here, the variable is h, not x. Okay? So x doesn't change in this expression. Okay, so the limit that's happening is with the h. So this turns out to be 0. So sine x, which is a constant in this because the variable is h and not x, times this, times cosine h minus 1, the limit of cosine h minus 1 over h, which is 0, plus cosine x, times the limit of sine h over h, which is 1. So the sine x gets wiped out by the 0, and cosine x times 1 is just cosine x. Alright, so that's the derivative of sine x, which is cosine x. Alright, that's the derivative. Okay, that's number 13.